I'm going to show you two different methods of evaluating limits algebraically in this video. The first method is called direct substitution, okay? So really, you just plug it in and see if it comes out to be an answer. Sometimes the direct substitution method doesn't work. You'll get 0 over 0, like something undefined. So I'll teach you how to do those ones later, but let's start with the basic direct substitution examples, okay? So they want us to evaluate the limit as x approaches 4 of this polynomial x squared minus 3x plus 7. All you need to do is plug in the 4 into the function. Okay, so you may want to have a scientific calculator for this. Let's see what's that going to be. 16 minus 12 plus 7, right? So that's what? 4 plus 7. The answer is 11. So when you are doing these limit problems, plug in first to see if it gives you an answer, okay? Like number 2 over here, I can try to just plug in this. What's the number? 3 into this function. Everywhere I see x, I will plug in the number 3. So that's going to be a big fraction. 3 squared plus 3 times 3 minus 1 on the numerator. And in the denominator, I will have 2 times 3 plus 4. Alright, so if I simplify this, I will get 9 plus 9 minus 1 over 6 plus 4. So the answer is, what's that on top? 18 minus 1, 17 over 10. That's an answer, alright? That's a fraction. So yes, we can just plug it in and see if it gives us an answer, okay? Let's do the third one over here. I'm going to plug in 5 into the x, okay? So let's evaluate that. This becomes square root of 5 squared minus 3 times 5 plus 2. That is square root of 25 minus 15 plus 2. What's that going to be? Inside the square root, we're doing 10 plus 2, right? So that's 12. Let's reduce this. Let's simplify this, okay? So you can break down 12 as 4 times 3, right? Because we can now say this is the same thing as square root of 4 times square root of 3. We know that square root of 4 is just 2, but square root of 3 is an irrational, so we'll just leave it in the square root. So you may see a homework problem that's asking you to simplify a square root expression, but these 3 examples that I just went over, we were able to find the answer by just directly substituting the x value into the expression, okay? Now, that may not always work though, so I will show you the second method now, okay? Let me minimize this a little bit. So I'm going to try to just do this by plugging in first, okay? And show you why that method does not work for these problems. So it says x is approaching negative 3. So everywhere I see, I'm plugging in negative 3, okay? So what will happen? Negative 3 squared minus negative 3 minus 12 all over negative 3 plus 3, and that's on right? If you add these opposite numbers, negative 3 and positive 3, what will happen to the denominator? Oh, that becomes 0. That becomes 0. You can't divide by 0 in math. And if you work out the numerator, I think that also comes out to be 0. Let's take a look. That's 9 plus 3 minus 12. Yes. So if you get this 0 over 0, okay, then you need to try a different method, okay? I'll show you a different method. And for this method, you will need to remember how to factor some trinomials, okay? All right, take a look. I'm going to factor and simplify first, okay? So this is equal to keep that limit expression. Keep on writing this until you plug in, okay? Limit as x approaches -3 of, all right, let's factor this. Let's factor that purple highlighted trinomial. What times what gives you 12? 4 times 3, right? But if I make the 4 a negative and 3 a positive, I'll be able to get -1x in the middle. All right, the denominator is just x plus 3. Well, what will happen to this rational expression is that x plus 3 will cancel out, leaving us with just x minus 4. So now it's time for us to plug in that -3. So this becomes -3 minus 4. So the final answer is -7. So if you plug in a number, usually a rational expression, a fraction expression, and they give you 0 over 0, you will want to factor and simplify first before you plug it in. Let's try another example here. Okay, I know what will happen if I plug in 2. The bottom will turn into 0, the top will turn into 0. So I'm going to simplify by factoring first. Okay, what's the numerator? Let's take a look. The numerator is x squared plus 4x minus 12. I can factor this into x and x. I think 6 times 2 gives us 12. Make the 6 a positive, make the 2 a negative, then they will add up to positive 4. So factoring's good. Now let's factor the denominator. Remember how to factor these types? That's difference of squares. That turns into x plus 2 times x minus 2. So this may be a lesson where you may need to brush up on your factoring skill, okay? All right, let's cancel some common factors out. I see x minus 2's will cancel out. The other guy survived. All right, let's write down the simplified expression. Limit as x approaches 2 of x plus 6, x plus 2. Now I'm ready to plug in. Plug in the 2. 2 plus 6, 2 plus 2. That turns into 8 over 4, and 8 divided by 4 is 2. So we went over two different methods of evaluating limits algebraically in this video. First method was just plug it in, direct substitution. But if that doesn't work and give you 0 over 0, you will want to factor and simplify first.